I'm going to show you guys how to derive that constant acceleration equation that has time and displacement and initial velocity in it. You don't have to know how to derive this. I just want you to see where it comes from, all right? And in case you're curious, but it is also just important to kind of see how this equation arises, all right? So first and foremost, we are going to start with what we call the first basic equation. Now, the first basic equation actually starts with the acceleration equation that you already know, which is acceleration is equal to the change in velocity or final velocity minus initial velocity over time. So we start with this equation, but then we're going to rearrange it a little bit so that we get a rearranged equation. Not a new equation, because it's the same equation, just in a different way. So I'm going to multiply both sides by time. So I get acceleration times time equals final velocity minus initial velocity. And then I'm going to actually add initial velocity to both sides. So I end up getting final velocity is equal to initial velocity plus acceleration times time. So this is called the first basic equation in physics. I'm going to leave that there though for a second, and we're actually going to go to a different equation. So this whole thing is basically four different equations all kind of put into one, all right? The next equation that we're going to look at is the average velocity equation. So the average velocity equation is the one that you learned for velocity. So that's V average is equal to the change in position or the displacement. So final position minus initial position over time. So this is called the average velocity equation because you can't use this equation unless you have a constant velocity. So if you have an acceleration, we don't really use this equation because it gives you the average velocity. It doesn't really tell you much about the initial or final velocities. Now, you can have an average velocity when you have an acceleration, but again, it doesn't tell you about the initial and final. When you have a constant velocity, though, the constant velocity is also the average velocity. So again, I'm going to rearrange this equation just like I did with the acceleration equation. So I'm going to multiply both sides by time. We get average velocity times time equals final position minus initial position. And then I'm going to add initial position to both sides. So we end up getting final position equals initial position plus average velocity times time, like that. And again, I am going to leave this here and come back to it. So next we're going to look at the other average velocity equation. So when we have, like I was talking about, an initial and a final velocity, if we have two things and we want to take the average, all we do is add them together and then divide by the number of items, right? So if I have an initial and a final velocity, those are two things. I then can say that the average velocity is equal to that initial velocity plus the final velocity divided by 2. So now, just like I did before, I'm going to actually solve this equation for final velocity. So I'm going to multiply both sides by 2. I get 2 times the average velocity is equal to initial velocity plus final velocity. And then I'm going to subtract initial velocity from both sides. So I get final velocity equals I get final velocity is equal to 2 times the average velocity minus the initial velocity, okay? And then from here, what I'm going to do now is I am actually going to take this last red equation for the final velocity and I'm going to plug it in to the initial purple equation. So I lied at the beginning. It's only 3 equations that we use, but we're going to get a 4th equation from it. So what I'm going to do here is I am going to take this right here and I'm going to set it equal to this right here because I know that final velocity equals final velocity. So here, because final velocity equals final velocity, I then can say that 2 times the average velocity minus the initial velocity equals velocity initial plus acceleration times time. I'm just setting those things equal to each other. This is supposed to be an initial velocity right there. All right, and then I'm going to add initial velocity to both sides to get rid of it on that left-hand side. So we get 2 times the average velocity equals 2 times the initial velocity plus acceleration times time. And then just to make it a little bit prettier, we're going to divide everything by 2. So we get average velocity equals initial velocity plus 1/2 times acceleration times time. Now, we're getting somewhere now, but we do not want this average velocity term in this equation or in that blue middle equation right there. So what I'm going to do now is I am going to take this equation right here for average velocity, and I'm going to plug it in to this equation right here for that average velocity. So now what we get is final position equals initial position plus that average velocity, which I know is v initial plus 1/2 acceleration times time times time. So now what I'm going to do here is I am going to distribute this time to both sides. So or both terms, I distribute it to that initial velocity and I distribute it to this term right here. And we end up getting final position equals initial position plus velocity initial times time plus 1/2 acceleration times time squared. And then all I'm going to do here, just to make it a little prettier, combine kind of like terms, is I'm going to subtract initial position from both sides because I know final position minus initial position is just displacement. So if I subtract initial position from both sides, I get displacement is equal to initial velocity times time plus 1/2 acceleration times time squared. And that is my final answer for my equation. So this is called the second basic equation in physics. And this is the equation that you want to use when you have a constant acceleration and you have an initial velocity and a time and a displacement, or maybe you're trying to find one of those things. A lot of the time too, when you use this, the initial velocity will be 0. So that initial velocity times time term will actually cancel out, all right, which is very helpful in calculations.